You see them everywhere, right? Skyscrapers, bridges, highways. But have you ever really stopped to think about what's going on behind the scenes? Not the steel and concrete, but the invisible architecture of decisions that turns a simple idea into a massive reality? Well, today we're going to pull back that curtain and look at the hidden math of construction.
So imagine you're driving and you see it, a brand new overpass, a gleaming office building just finished. And maybe you think, who decided to build that? And how on earth did they know it was worth spending millions or even billions of dollars? Let me tell you, it's definitely not a gut feeling. It's a high-stakes calculation where one tiny mistake can cost a fortune, and it all kicks off with one surprisingly simple question. Believe it or not, every massive infrastructure project starts in pretty much the same way you'd plan a kitchen remodel, with a rough, back-of-the-envelope question. Before anyone even thinks about drawing a blueprint or breaking ground, somebody has to ask, okay, roughly, how much are we talking here? $1 million? $100 million? Getting that ballpark number is the very first and most critical step.
And that brings us right to our first stage. We're calling it the billion-dollar guess, which sounds a bit dramatic, but really, it's all about the methodical process of turning a vague idea into a number that's solid enough to actually build on.
See, every project really goes through two key phases of estimation. First up, you've got the preliminary estimate. This is your quick, back-of-the-napkin calculation, just to see if the whole idea is even feasible. But to actually get the real green light, you need what's called a detailed estimate. This is a meticulous, line-by-line breakdown that accounts for every single bag of cement and every hour of labor. One is about possibility, the other is all about reality.
Now, here's the thing. These estimates, they aren't just polite suggestions. They have real teeth. If the final cost of a project ends up being more than 5% over the sanctioned estimate, everything just grinds to a halt. A formal revised estimate has to be drawn up and approved all over again. That 5%, that's the absolute line in the sand.
Okay, so once a project is considered financially feasible in those broad strokes, the focus shifts, and it shifts dramatically. We go from the big picture to the microscopic details. We're moving out of the what-if stage and into the how-to stage.
And the level of obsession required here is just incredible. We're not talking around 10 meters. No way. We're talking about measurements that are accurate down to the centimeter. Every single area, every single volume is calculated with extreme precision. This isn't guesswork. It's geometry on a massive scale. And it's the only way you can build an accurate budget. Now, alongside those super precise measurements is another critical document, the specification, or spec for short. Think of it as the project's official rulebook. It's the document that makes the difference between getting granite countertops or getting laminate. It legally defines the quality of every single component, from the exact type of steel to the precise proportion of sand in the mortar.
But specs do something else that's really vital. They ensure fair competition. See, you can't just write a spec that says you must use brand X concrete. That would totally lock out all the other competitors. Instead, the rules are clear. If you absolutely have to name a brand, you must add the magic words, or equivalent to. This keeps the whole bidding process open and fair.
Okay, so we have a hyper-detailed plan. We know the exact quantities and the quality standards. Now comes the multi-million-dollar question. How in the world do you put a price tag on every single piece of it?
Well, it breaks down into three main parts. First, you have your prime cost. That's the raw stuff, right? The materials like steel and concrete, and the direct labor, the people actually putting it together. But hey, projects don't run themselves, so you add on overhead. These are the indirect costs, like project management, office space, insurance, the whole shebang. Prime cost plus overhead gives you your total cost.
And the labor cost isn't just a random guess either. It's based on standardized data called outturn norms. Planners know exactly how many square meters of plaster a mason is expected to finish in an 8-hour day, or how much earth a worker can excavate. This data turns labor cost into a predictable variable, not some wild guess. So now we have it all: a precise design, a detailed plan, and a reliable total cost. All of that incredible work has led to this one single monumental moment, the go/no-go decision. Is this project actually a worthwhile investment?
To answer that question, we need to bring in a core concept from economics, the time value of money. It's a simple idea. A dollar today is worth more than a dollar a year from now. Why? Well, because you could invest that dollar today and it would grow. It's the reason winning the lottery and getting a lump sum now is totally different from getting paid out over 20 years. Pretty much all major financial decisions hinge on this one idea.
This brings us to the key tool for making that final call, net present value, or NPV. It's this powerful calculation that answers one fundamental question. After you add up all the money a project will make over its entire life, and then subtract the initial cost to build it, all while accounting for that time value of money, are you left with a profit or a loss?
So, what are you looking for? A positive number. It's that simple. Any positive NPV, like this example of $2.5 million, means the project is projected to earn more than it costs. This is the financial green light. The project is a go.
But worthwhile can mean different things to different people. For a private developer building an office tower, they use a financial analysis. The question is simple. Is this going to be profitable for me? But for a public project, like a new highway, analysts use an economic analysis. And that asks a much broader question. Is this beneficial for society? This looks at value that goes way beyond just dollars and cents.
For those public projects, the decision often comes down to what's called a benefit-cost analysis. Basically, they estimate the total monetary value of all the good stuff, like less traffic or improved safety, and they divide that by the total cost. As long as that ratio is greater than 1, the project is considered a net positive for everybody.
And all of this, the estimation, the detailed planning, the financial modeling, it all serves one big purpose: to allow us to build with confidence, knowing that a project isn't just physically possible, but that it's financially and economically sound.
So let's just recap that journey real quick. It all starts with a broad question about cost. That then evolves into an incredibly detailed plan. From that plan, a precise cost is calculated. And finally, that cost is weighed against all the future benefits to make a final, justified decision. It's a clear, logical, and really powerful process.
You know, this quote from our source material just sums it all up perfectly. This isn't just about accounting. The entire field of engineering economics exists to answer 3 fundamental questions. Is this the right thing to build? What is it truly worth? And can we justify the investment?
So the next time you find yourself stuck in traffic, maybe looking at a new construction project, I hope you'll see it a little differently. Not just as a collection of steel and concrete, but as the final, physical result of this immense, invisible process of calculation, justification, and decision-making that made it all possible.